Now let's move on to the ellipse. Ellipse. Okay, so there's two different types of parent functions for ellipse. There is x squared over a squared plus y squared over b squared equals 1. And there is x squared over b squared plus y squared over a squared equals 1. These are your two different forms, and then we're going to do the exact same thing. We're going to add the minus h and the minus k to these top portions. So now it's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1, or x squared over b squared, x minus h squared over b squared plus y minus k squared over a squared equals 1. Those are your two forms. Wow, that's horrible. I'm going to move this. My bad. Equals 1. Got it? So these are your two forms. These are the guys you got to memorize. This and this form. The only difference between these two forms is where b and a is. And if you guys remember, the only difference between a and b is they're not variables. All they are is they're denoting the higher number. So a is the higher number, and it's going to show you the vertex. And b is the lower number, and it's going to show you the co-vertex. So that's really, so pretty much they're the same. The only difference is you're going to be saying, is your ellipse dominant on the y-axis, or is it going to be dominant on the x-axis? So that's how that works. And then h and k is going to be your center for the ellipse. So I'm going to give you guys a sample problem, and we are going to graph it real quick so I can show you guys how to graph an ellipse. So we have x minus 4 squared over 13 plus y minus 2 squared over 4 equals 1. So I'm going to put my graph over here real quick so I don't run out of space. And then I will start giving you guys steps and so on and so forth. All positive, so I don't need to worry about the negative axes, and that'll work. So our first step is going to be find h and k, which is our center. H equals 4 right here, and k is going to equal 2. H equals 4, k equals 2. And then our next step is going to be to find our outer points. So our outer points, if the origin was 0, is going to be negative and positive A, negative and positive B. So let's find A and B real quick. So if we look here, our A is going to equal the square root of 13, because this is that. You need to square it to get this, so that's that. And then B equals 2. So we have our A and our B, we have our H, and we have our K. My whiteboard is falling. Give me a sec, guys. Alright, we're good. We're back. Alright, so our A and our B, H and K, that's exactly what we're looking for. So the next one that's going to be important is we also want to find our C. Our C stands for, is pretty much the distance from your center point to the foci. So let's get that real quick. If you guys remember, the formula to get your foci is going to be C squared equals A squared minus B squared. So C squared equals 13 minus 4. C squared equals 13 minus 4, which is 9. C equals 3. So our C is going to equal 3. So we have A, B, C, H, and K. We've got pretty much everything we need. And now we can graph. So I'm going to do my little check marks real quick. 3, 4, 6. 1, 2, 3. Alright. So our first point is going to be our center, which is 4 and 2. 1, 2, 4, 1, 2. As I said earlier, all we are doing is you're transforming the origin of 0 over 4 and up 2. That's all you're doing, and boom, we have our center right here. Then, what you're going to do is just like when you counted square root of 13 up and square root of 13 down for A, and B was 2 over and 2 that direction, you're going to be doing a similar idea. Actually, my bad. A is under X, so that's side to side, B is up and down. So you're going to, instead of counting that from here, you're going to be counting it from over here. So what I'm going to do is I'm going to count 2 up and down from my graph. So I would take this, and I would go 1, 2, 1, 2, and then I'm going to count square root of 13. Square root of 13 is about 3.6. So I'm going to go 1, 2, 3, about 3.6 right here. And sorry, let me fix this. Just put this and this. 1, 2, 3, 3.6 is about right here. And now we have an ellipse. There you go. That's our ellipse. It's not the best ellipse because I'm not perfect, but it's pretty good. So this is our ellipse. This is the center. These are our different points. This right here is the co-vertex. And this is the vertex. And that's what's cutting our graph into 4 points. Alright, now the next one is you want to get our foci. So we're going to count 3 points from the center towards the outer points here and here. So I'll go 1, 2, 3. One is right here, 1, 2, 3. The other is right here. These are our focus points, this one and this one. And there you go, that is our graph. Now I want to show you guys something real quick. Yes, I did transform everything. What's important to notice is the foci did not change. You don't do any transformation for the foci because all C is the distance from here to here. So you don't need to change that because no more is going. A and B is very interesting because if you look, when we learned about this, all we would do is you would do, say A is under X, so all you were doing is you were doing square root of 13, 0. This is what you would be doing if the origin was 0. Over the square root of 13 over here and you would be done. But what we're doing is we're counting it from here. So either you can just graphically count over, or if you want, you can just transform that by our transformations right over here. So all I would have to do is square root of 13 plus 4 and 0 plus 2. This would change to 4 plus square root of 13 and 2. And if you look, that works for this point. 1, 2, 3, 4 plus 3.6. 1, 2, 3.6 up 2. There you go. All we did is we transformed this point to this point. So you can do it graphically like I did, or for every point you can do that. And that works for all points for the ellipse, and that's how that works. And that is how you graph an ellipse. So you have our foci doesn't change. Your A and your B you count from the center, or you transform the individual points by H and K. H for the X, K for the Y. And then you also have your co-vertex and your vertex, which are just going where they should be. And that is how you graph an ellipse. Alright, now we're going to move on to the hyperbola.